Hello everyone, and welcome to Summarize Science. Today, there's an exciting method to discuss that helps ensure AI language models, or LLMs, stick to the rules. LLMs are being used more often for things like writing documents and helping customers. It's super important they follow company policies. The traditional methods of monitoring for policy violations have limits, but this new method offers a solution. The research introduces a training-free way to detect when these AI models step out of line, focusing on the activation space within the AI. The approach treats the problem of detecting violations as identifying when the AI is acting strangely. They use something called activation space whitening, a technique that adjusts the internal workings of the model to make it easier to spot unusual behavior. But they don't actually need to train the model on lots of specific examples of good and bad behavior. The process involves decorrelating the model's hidden activations and standardizing them. This creates a space where it's easier to measure how well the AI is complying with the rules. Researchers use the Euclidean norm as a compliance score to catch policy violations in this transformed space. The method only needs the policy text and a small number of example samples. It's very lightweight and easy to use. In tests, the method has achieved better results than existing systems. It surpasses both existing guardrails and fine-tuned reasoning models. Figure 1 illustrates the entire approach, where organizational policies define the expected behavior. A user query results in an output, and a whitening transform is applied to the model's hidden states. A compliance score is calculated, and those responses whose whitened norms exceed a threshold are flagged. Figure 2 shows the compliance calibration, including activity extraction, modeling, and distribution, and how scores are calculated. Figure 3 shows the online compliance detection process. A runtime user LLM interaction goes through activation extraction, uses a whitening matrix, and then a threshold is compared. The method's ability to work directly within the activation space of LLMs is a game changer. It's training-free, lightweight, and interpretable, all crucial for practical deployment of AI governance. By modeling compliant user interactions as a standard, any deviations are flagged, making it easier to catch violations. It's adaptable for both white box and black box settings, meaning it can be used whether you have full access to the model or are using a closed API. Figure 4 shows the statistics of LLM activations before and after whitening, where whitening results in approximately zero mean. Figure 5 shows a parameter ablation study, highlighting the robustness and efficiency of the method. Figures 6 and 9 show that distinct internal dynamics can occur across layers. Table 2 and 3 show benchmark results and runtimes, highlighting the performance and speed of the method. This method outperforms existing systems, including those that fine-tune models, without requiring the fine-tuning or external evaluators. The ability to continuously monitor and update policies makes it highly effective. This training-free activation space framework offers a promising avenue for ensuring that AI language models are used responsibly and ethically. By making AI governance more practical and interpretable, this work advances the goal of creating trustworthy and reliable AI systems that align with human values and organizational policies.